Thank you for watching point cloud extraction with semi-global matching from Hexagon Geospatial eTraining. In this video, we'll see how to extract a point cloud DTM with LiDAR-like quality using the Imagine Auto DTM package for Imagine Photogrammetry. Once extracted, the point cloud layer can be viewed like a true ortho, providing a 3D view that can be analyzed and measured. I'll start with Imagine Photogrammetry open and a block file loaded. This block has been set up with all the information necessary to run and complete triangulation. With the triangulation results accepted, I can now run Imagine Auto DTM. In this module, we'll focus on extracting the DTM using the Semi-Global Matching Algorithm, or SGM. I can start the DTM extraction process by selecting the Generate Semi-Global Matching from the Photogrammetry tab. This launches the Semi-Global Matching dialog box. The first tab in this dialog box shows current images to be used in this semi-global matched output. The pairs with overlap percent value determines the overlap percentage required for an image pair to be considered in the DTM extraction process. To consider more image pairs, this value can be changed to a lower value. Semi-global matching can run with a minimum amount of overlap. I can change the overlap value to something very low, for example 5%, to include all image pairs in this block. However, setting this value too low can create redundancy, so I'll change it back to 55%. I could also remove the check marks in the active column to manually deactivate any stereo pairs and prevent them from being included in the SGM algorithm. Semi-global matching requires overview layers generated by ImageStation raster utility. These layers are similar to the pyramid layers generated from Imagine. If the overview layers are not present, the green boxes under pyramid will be red. Simply click on the red box and follow the steps to generate the overview layers. Here we see a green color in the pyramid column letting us know that the layers are present and can be used to run the algorithm. Next we'll look at the Strategy tab. First we'll set the color bands to match. For best results, you want to select the band with the highest contrast. If you're unsure, you can view the images as a single layer in a viewer and see each band separately. When in doubt, in most cases, the best option is green. Changing the pyramid layer level can speed up processing time. Pyramid layer 0 has the highest resolution of the pyramids, and they decrease in resolution as you increase the pyramid level. By changing this to stop at the first pyramid level, it can make the processing twice as fast, but you can lose resolution in the output. If you can, it's best to leave this value set to 0. The disparity difference is for blunder checking. If your output is not as accurate as you had hoped, and you see blunders in your output, this value can be changed to increase accuracy. If you're working in an urban setting, you'll want to choose the Urban Processing option so it takes into account building edges and other urban features. This is essential for proper urban output. Place a check mark next to Keep Vertical Surfaces if you're working in an area with vertical surfaces like buildings or cliff edges to increase the output accuracy when this type of feature is present. Finally, we have output options. First, define the output directory where the output will be saved. Next, if you want to clip the output based on corner coordinates, you can add a check mark next to 2 corners and define the coordinates. SGM will create 2 output files, one with full resolution and one that has been thinned. The thinned output will have a smaller file size and contain fewer points. Select between mild, medium, or aggressive thinning. The generated point cloud can be encoded. To create an encoded output, activate this option and select between RGB or false color infrared. This should be selected based on the imagery type you're working with and your project needs. The imagery in our example doesn't have infrared, so I'll select the RGB option. You can also choose to generate a raster output. The raster output is generated by rasterizing the extracted point cloud, creating an image that has near true ortho quality. We can either run the output to generate the point cloud layers, or we can use the Submit button to define a batch process, or use distributed processing with Condor. Batching allows us to select a date and time to run the process in addition to defining the number of processes that can be run simultaneously. Running multiple processes can greatly reduce project processing time. The number of simultaneous processes available is based on the number of processors in your computer and your software license. In this case, we have 3 image pairs, so we'll tell the software to run all 3 processes at the same time. I can now click OK to run this process. Once the processing is complete, I can load the point cloud layer into a viewer. I can select File, Open, Point Cloud Layer, find the point cloud to load, and click OK. The layer is loaded as a raw point cloud colored using elevation. From the Display group on the Point Cloud tab, I can use the Color By menu to change the display type. Since we created an RGB encoded point cloud, I can select RGB to see the point cloud in true color. Finally, I can open this in a 3D viewer. We can zoom in to see more detail. If we zoom in further, we start to see individual points. There are a few different ways of viewing the point cloud. First, we can view the points themselves as we see now. Second, we can use the display tools to increase the point size. This helps fill in the gaps between the points and can make the point cloud look more like an image in the viewer. Finally, from the 3D group, we can activate triangle mode. Because this point cloud was generated from imagery, points can only be extracted for areas where image pixels exist. Triangle mode tins the points and fills in the gaps along the walls, vertical surfaces, and places of missing data. Thank you for watching this Hexagon Geospatial eTraining module on point cloud extraction with semi-global matching. For more eTraining, please visit the customer support site, log in, and follow the link on the right to eTraining.